Hello and welcome back to another easy LeetCode problem. This is another classic problem. It's LeetCode 125, valid palindrome. As usual, let's go through the problem description, understand the constraints, formulate an idea of how we're going to solve it with the runtime and space complexity analysis before we write the first line of code. So let's dive into this. A phrase is a palindrome if, after converting all uppercase letters to lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. Okay, there's an upper bound on the length, and we are guaranteed to have at least one character in the string. And S consists only of printable ASCII characters. All right. Let's look at an example. So we have a sentence, right? And there's a man, a plan, a canal, Panama. And it's actually a palindrome. Interesting, because A matches with this A, because we lowercase everything, right? Then we ignore the space. Then we have the M here, the M here, the A here, the A here they match. This N matches with the next N. This A matches with this A because we're skipping the non-alphanumeric comma and the space. And we continue. And okay, nice. And here, raise a car is not a palindrome because if we remove all alphanumeric and non-alphanumeric characters, we get the word raise a car, and that is not a palindrome. It doesn't read the same forward as it reads backwards. The empty space is a palindrome. Interesting. So this is an edge case because if we remove all non-alphanumeric characters, we get the empty string, and by definition, an empty string is a palindrome. Okay, so there are several ways of how you can approach this. You could do exactly what I just did with having a pointer that points on the left side, and on the right side, and we advance those pointers every time we have a match, and we skip over indices that are not alphanumeric, and we just continue this process until we run into a mismatch between the left and the right character, in which case we return false. Or when both pointers meet, we can return true because we didn't find any mismatch when we compared it. That would be a linear time algorithm with constant space because we only need to keep track of the pointers. Another approach, which would be, I guess, more naive, would be to, well, take the string, lowercase it, remove all non-alphanumeric characters, and then check if it's a palindrome or not. The reason why I came up with the other algorithm first was because that's exactly what I did when I went through the example. And as a reminder, it's a really good idea to step through the example and see how you would solve it by hand, because that typically gives you a blueprint for how you could solve it with a Python program. So yeah, the second approach would be O of n time as well, because we need to process all of the characters. But it also would be O of n space because we would have to construct a new string. So I would say let's just implement the second approach that is less optimal. Time and, yn squared, O of n time and O of n space. And for that we would simply, well, iterate over all of the characters. And we could do this in Python with a one-liner actually. So C dot lower. Dot lower is a function that lowercase is a character in Python. So that's, you have to know that. For C in S if C is a num. That's another function in Python that you can call. So this will return true on any string or character if that string or character consists of only alphanumeric characters. Yeah, and so now S, when we do this, we get a new string S that contains only the alphanumeric characters. Well, actually, we're getting a list here, strictly speaking, not a string. you would still have to convert it into a string if we wanted to. But we could already use the list, right, to check whether it's a palindrome. We could say, you know, it's a palindrome if this list is the same as the list when we reverse it. So that would be a solution that we could use. And yeah, let's try to run this. Let's see what happens. Yeah, and that instantly works. And what's also fun is to just print. Let's see what we get. Print S. So that will be our before. And because you have so little visibility of what you do, sometimes it's fun to just print some of the intermediate step after immediate steps. It's also good to do that during well, when you need to debug your code. So this is the empty string. So before it was an empty string, then it's an empty array. The second case, raise a car. You see that the spaces have been removed, so they're not in this array anymore. And in the first example, you can see that we don't see anything here. Why not? There you go. So here is not showing me the first one. Oh, there you go. Yeah, as you can see that everything that is not a letter or digit has been removed, and there are no digits in here. So yeah, so that would be the first way to solve it. Let's submit it to see if it gets accepted. I said the first way to solve it, but I mean the naive way. And now let's use the pointer approach, where we reduce the space complexity to constant space. So with the pointers, I always like to start like this. So we have a left that points at the first position, and then we have a last that points at the last position, and then while left is smaller than right, because if they're equal, then we know they can't be different. So while that is the case, we are going to do our comparison. And if we finish this while loop, at the end, we will return true. And if we find a mismatch inside the while loop, we would return false. So C1 is, or the left character is S at string position left, and the character right position is S at index right. There we go. So, and we could directly do a lower if we want to, just lower. Lower won't throw an error when you try to do lower under comma or a space. I think it just gets ignored. So we have that, and now if left is alnum, well, or maybe first, if it's not alphanumeric, well, that means we need to increase left and just skip over it, right? So we do left plus equals 1, and we continue our loop. And we do the same for here. If right the alphanum, then we're going to decrease the right one. If it's not alphanumeric, then we decrease it. So now when we're here, it means that both the left and the right are alphanumeric, and we just have to do one more check. If it's not the same, if the two characters are not the same, we're going to return false. So that's this approach. Let's run that one. Okay, typo. Okay, that thing doesn't exist. But it does now. Oh no, we still have an error. I made this error so many times. We actually have to decrease the left and the right pointer afterwards. Left plus equals 1, right minus equals 2. Otherwise, we're going to get stuck in an infinite loop when the left and the right character are same. Okay, cool. Oh well, I wish I could type. There you go. And right C is obviously wrong. We have to increment right, decrement right. You can tell that I'm not really focused, but yeah, I think we're getting there. So let's submit this. And there we go. So that's pretty much it. I don't think anybody else has a faster solution. How could they? We need to look at all of the different characters, right? So the best is over in space, etc., etc. And this is a classic problem, so you should be able to solve this, hopefully without any errors like I just did. So yeah, happy implementing.